Good morning. Okay, if you printed off your note packet so that you can take notes right on it, just flip to the back side of the page and you can do these right on that. If you didn't and you're just taking notes on your own, that's fine. Just go ahead, do me a favor, pause the video and then give it a couple minutes to try and answer these questions before we look at them together. No, really, pause the video. Okay, so now, I said it yesterday, we'll say it a bunch of times. Again, the answer to a log problem is what? Nolan, what do you think? Yep, it's an exponent. Okay, and then last semester we solved for inverses of functions. And first we made sure they were in the y equals form. So for example, y equals 2x plus 1, whatever, that's just an example. And we said to create the inverse of the function, we needed to trade the x and y value and then do what, Daniel? Yep, solve, trade the x and the y, and then solve for y. Okay, but yesterday we talked about exponential functions and this new kind of function that we're doing. And we said the whole reason that we are even looking at them is because exponential functions have an inverse. And what kind of functions are they, Joshua? Yep, they are log functions. Or logarithm functions. Okay, we'll just keep calling them logs. It's way easier, way shorter. And I'm trying to minimize my tapping noise on the screen for you guys. Okay, so on your page of notes there, looking more at 15.1 and looking at the graph of the inverse. So f of x equals 3 to the x power, of course, is the same as y equals 3 to the x power. And if I complete my chart, 3 to the 0 power is, of course, 1. 3 to the first power is 3. 3 to the second power is 9. And 3 cubed is 27 because we're multiplying by 3 each time. And then remember, of course, the pattern is if you're multiplying by 3 each time as the numbers get bigger, you're dividing by 3 each time as the numbers get smaller. 3 to the negative 1 will be a third, and 3 to the negative 2 will be 1/9. Okay, so if I graph that, I'm going to scroll down here. And if I graph those points, maybe I zoom in a little, I get 0, 1, 1, 3, 2, 9, and 3, 27 is, of course, off the chart. Negative 1 gives me a third, negative 2 gives me a 9th, and just like what we were working with in Module 13, we're going to get a graph like that. Okay, let me go back up. Okay, so we did a graph of that one. Now, the inverse, again, we said the inverse of, I'm going to pick a different color. The inverse of an exponential function is a log function. So I'm not going to work with the f of x version. I'm going to work with the y equals 3 to the x version. And so log base 3 of y equals x. Because again, the answer to a log problem equals the inverse. Okay? And then I can make a chart based on this. But if I already have this other chart, what do I do for my inverse? Trade your x's and y's. So That's going to be 27.3, 9, 2, 3, 1, 1, 0, 1/3, -1, 1/9, -2. Okay, and then I am going to go down and graph that. So I'll make that graph bigger so it's easier for you to see. Okay, so now again, these these values are a little more unique there, right? So 1, 0, 3, 1, 9, 2, and 27.3 is going to be somewhere off here. And then 1/3, -1, 1/9, -2. And again, it's going to go like this. And I'm going to draw. This is not an asymptote. It's the line y equals x. And if you notice, if I were to have this on a piece of paper, and if I took that piece of paper and folded it along this dotted line, my red graph would line up with my blue graph. And that's because that's what an inverse is going to do. It reflects over the line y equals x. Okay, and then domain of my inverse and range of my inverse. Well, what was my domain of my function? Right? Just like last chapter, we said, well, x can be anything. Now, what about your range? Well, look at my red graph. My red graph is going to be all the numbers that are bigger than 0. So y is greater than 0. So for my inverse, what's going to happen? Instead of my y's being bigger than 0, my x's are going to be bigger than 0. I'm not going to have negatives. And then what's my range? What numbers can I have for y? All real numbers. Okay. And then little last question here. Can I do base to an exponent equals 0? So in other words, can I take something to the x power and get 0? Nope. Okay, and so remember, just if I look back up at my red chart here, for example, then what happens? I divide when I'm going from the bigger numbers to the smaller numbers. If I continue to divide by 3, will I ever get to 0? No, that's why we have an asymptote there. So when I look at this, can b to the x power equal 0? No. So if that's the case, then can I also have log base 0 equals x? Nope. Right? Because the answer to the log problem is an exponent. And are you going to get an exponent if that number was 0? No. Okay, so now you guys are going to go back to that worksheet you did yesterday. You're going to do number 13 and then submit to Google Classroom. Please. Okay, have a great day. See you tomorrow.